Dear students, let's start lecture number 18 on the topic data encryption standard algorithm, and normally it is called DS algorithm, and this is part number 3. As you know that we have covered two parts of this algorithm already, so this is part number 3. So let's get started with the outline. Uh, we will be revising data encryption standard DES part 2 first, and then we will be studying data encryption standard part 3. As you know, you can see here I have shown the diagram for the illustration that at the beginning you have passed 64 bits to DES, and then it is passed to initial permutation, where the permutation means that jugglery of bit position. So 64 bit plain text were reduced to 56 bit, as the each bit of the final byte is used for parity checking, and then it is passed to round 1. And in the round 1 you have a different operations. Like first operation was key transformation. In the key transformation, name indicate that it transformed the 56 bit to 48 bits. So this means that key generator operator, this converts 56 bit to 48 bits. So sub key of 48 bit will be issued to each round. So as we have 16 rounds, so 16 sub keys of 56 bits will be issued. So and then the output of this will be passed to expansion permutation, as we covered this in our part number 2. So as we are revising it today, so I'll be explaining that more. And then S blocks, this is also we covered in part number 2. And now this is our today topic, that P box permutation, XOR and swap operation. And then after all the rounds we have final permutation. So I'll be explaining that how final permutation is done in DES, and then I'll be showing the sources cited, and then question answers. So let's get started with lecture number 17. So data encryption standard algorithm part 2. Here you can see that, as I have explained, that for before starting your DES algorithm, you pass 64 bits to the 64 bit plain text. So this will be permuted and compressed to 56 bit, as one bit will be used for the each byte, using one bit for the parity checking. So 6 will be discarded after this. So you will be left with 56 bits. So in expansion permutation, during the expansion permutation, then the output of this initial permutation will be passed to the key transfer round 1. And in the round 1 you have the first operation, that is called key transformation. So during expansion permutation, the right plain text is expanded from 32 bit to 48 bit. As you know that in transformation, you have divided into two halves. Like in the key transformation, you divided the text which is received from which was received for initial permutation into two halves. So each were of size 32 bits. And now in expansion permutation, as the name suggests, that expansion. So what you are doing, that the right plain text is expanded from 32 bit to 48 bits. Beside increases the bit size from 32 to 48 bits, the bits are permuted as well. So there are two functions that are performed in round 1. So one is called expansion. So expansion will be done from 32 bit to 48 bit, and then permutation will be performed. Hence, the name suggests this is called expansion permutation. This happens as follow: the 32-bit write plain text, which is received from key transformation, is divided into 8 blocks, as you know, each consisting of 4-bit. Next, each 4-bit is then expanded to a corresponding 6-bit. So how this will be expanded? So per 4-bit block, 2 more bits added. Definitely, if you are increasing from 4 to 6, so you need to add two bits in each block. So they are actually they are actually the repeated first and fourth bit of the 4-bit block. So doing that, you will be converting 4-bit to 6-bit block each. This is an example. You can see with the help of diagram that you have received 32-bit write plain text, and each of 4-bit, each one is of 4-bit size. So first, you can see here that the fourth and first, this will be repeated in each block. So you will be receiving 6 bits. So the 4-bit block will be expanded to 6-bit block. So now you will be having 6 blocks. Sorry, you will be having 6-bit block. So expansion permutation. Firstly, the key transformation process compresses the 56-bit key to 48-bit bit. As you know, this thing that how it is performed. We have studied key transformation in our previous lecture. Then the expansion permutation process expands the 32-bit to 48-bit, as you know. Now the 48-bit bit key is XORed with 48-bit write plain text, and resulting output is given to the next step, that is called S-box substitution. So this way, so after expansion, this will be received by the X-box substitution. You can see here with the help of example. You can understand this with the help of example, that here we have key transformation. So compress the key from 56-bit to 28 bits. And here expansion will be expansion permutation will be done, and write plain text will be expanded from 32-bit to 48 bits. So after that, both will be XORed, and the result of the XOR will be passed to the S-box substitution. So after receiving this, receiving the output of the expansion permutation, S-box substitution that accepts 48-bit bit key, as you know this. From the XOR operation involving the compressed key and expanded write plain text, produces a 32-bit outcome using the substitution technique. So the substitution is performed by eight substitution boxes called S boxes. I'll explain that with the help of example, or with the help of a diagram on the next slide. So each of the write S box has a 6-bit input and a 4-bit output. The 48-bit input block is divided into sub block, and each such block is given to S box. The output of the X boxes are then combined to form a 32-bit block, while each is given to the next stage of a round, and the P box permutation passed to the P box permutation. So you can see this with the help of example, that you have 48-bit input block that is received from expansion permutation. And then this is divided into 6-bit sub block each, and then this will be converted to X boxes, and then these X boxes will be combined to obtain 32-bit output block. So then this output block will be passed to the next level, that is called P box substitution. So we will explain that in our lecture number 18. So let's start today's lecture, that is on data encryption standard part 3. So we will Today we'll be explaining P box permutation. As you know that in X box has, as you know that in the previous slide, 32-bit output block is produced. Now this will be passed to the P box permutation. So the output of the S box consists of 32-bit, as we know. So these are permuted using P box. This involves simple permutation, as the name suggests, permutation. So this is jugglery of bit position, like you can see here in the diagram. This involves simple permutation, swapping of each bit with another bit without any expansion or compression. This is called as a P box permutation. So here you can see that we have 32-bit input, and each is replaced with its corresponding numbers, like 1 will be replaced with 6, and 2 will be replaced with 3, 4 will be replaced with second, and so on. So this is how permutation is done, and once the output is produced, so this will be passed to the XOR and swap operation. So now let's move to the next level, that is called XOR and swap layer or a function. So all these operations are performed only on 32-bit right half, as you know this. Portion of the 64-bit original plain text, that is on the right plain text, the left half portion LPT was untouched. So left side, I think you know this thing from the fiscal block structure, which we have studied in our previous lectures. So as DES is based on fiscal block structure, so in that model, the left was untouched. So similarly, the left half portion of the left plain text was untouched. The left plain text is now XORed with the output produced by the P box permutation. I'll show that with the help of diagram on the next slide. The result of this XOR operation becomes the new right half, and the old half right becomes the new left half, and in a process of swapping. So as you know that here we have two operations. So XOR operation will be performed and then swapping. So left will become the right plain text, and right plain text will become the left plain text. So you can see that here with the help of example, I'll explain this with the help of example, that you have XOR and swap operation here. You have 32-bit plain text, and here once the operation is performed of round 1, this will be XORed with left one and passed to the right side, and the right side will be passed to the left side. So we have two operations, like XOR operation and the swapping operation, you can see here. So this is called swapping operation. So left will become right and right will become left. Before going to next slide, which is on final permutation, I want to show the general structure of DES for explanation. Like you can see here that you had passed 64-bit plain text to initial permutation. What initial permutation does, that it compresses the 64 bits to 56 bits. As you know that 1 bit is used for the parity checking, and then it will pass to the round 1. So you have 46-bit, 48-bit key. So 56 will be converted in the key transformation operation. 56-bit cipher will be converted to 48-bit, and this will be passed to 16 rounds. So 16 sub keys will be generated from of size 48-bit from 56-bit cipher. So 16 sub keys will be generated from 56-bit cipher key. So after performing 16 steps, so final permutation will be done, and the result of this permutation you will be getting 64-bit ciphertext. So now final permutation. So like initial permutation, final permutation is also performed at the end of 16 round, and this is performed once. This is a simple transposition. Like for example, the 40th input bit takes the position of the first output bit, and so on. So this is just a jugglery of position, as you know that, as you know the function of permutation. In the permutation, you just change the position of bits. The output of the final permutation is the 64-bit encrypted block. So once the final permutation is performed, you will get 64-bit ciphertext. So once again I want to explain this with the help of the journal structure. Like initially you pass 64-bit to 64-bit plain text to the initial permutation. So what initial permutation performed, that as permutation, I have explained this many times, that jugglery of bit position. So this will be, permutation will be performed, and your 56-bit 64-bit will be left with 56-bit, because the one bit will be used for the parity checking. And then 56-bit cipher key will be used by the key generator to produce 48-bit key sub key for each round. So you will be having 16 different keys. So as I mentioned, that I have explained the function of round one. So the remaining rounds, like you have round number 2, 3, and up to 16 in DES. So they have the same working, as the working of round one. So once all the rounds perform their operation, this will be passed to the final permutation. In the final permutation, the jugglery or replacement of bit characters will be performed again, and finally you will get 64-bit ciphertext, and this will be passed to the DES. So this is the process of encryption. Remember, because if you remember that when you have a plain text and you apply the process of encryption, you will get ciphertext. Ciphertext means that nobody irrelevant cannot read it. So this is unreadable format. So you will get 64-bit ciphertext. So this will be done by the sender, and once the sender sends this to the receiver will perform the reverse operation of this. So in the next lecture, I'll be explaining that how the reverse operation will be performed on the receiver side. So I'll be explaining that in part number 4. So this was the final permutation. So once this is done, so you will get the get 64-bit ciphertext, and this will be passed to the receiver, and then receiver will perform the reversal of this DES to get the plain text back. So these are the sources which I have cited for the creation of for the creation of this lecture. So you can go through them. If you have any question or you want to explore more about this topic, then you can go through and explore more about this topic. In case you have any question, you can ask me through KCMS or WhatsApp, or you can see here my email address is mentioned here. You can email me. I'll be more than happy to answer your question. So with that, thank you. And we have one more lecture on DES. That would be part number 4. So in that we will be explaining the reversal, or the you may call it the decryption of DES process, and then I'll be explaining the decryption and the different variations which are available of the DES. I'll be explaining that. So with that, till then, Allah Hafiz. So bye.